Hey guys, welcome back to the channel. So why do we use relays? Relays are normally in circuits with high current demand. So fuel pumps, electric water pump, radiator fans, headlights, just because of the simplicity. Um, and there's in other future videos where I'm going to show you other options like solid state type relays that are kind of what we're using today, state of the art, where we actually don't use relays and we don't use fuses, but that's for a future video. So let's get started. I'm going to draw up a few different relay circuits and explain what they are, and let's get to it. We'll start with this right here. We've got a fan relay. It's drawn out. So all relays, the pin assignments are pretty much the same. So on 30, that's your power into the relay. 87 is the power out of the relay when the coil is activated. 85 and 86 control the coil. So on this relay, we got power in on 30. We have ignition coming in on 86. And we have pin 85 was the ECU trigger. So when the ECU demands that the fan be turned on, it'll send a ground signal, ground 85, energize the coil, send power out of 87 to the fan. Anyway, so we're going to do a fuel relay. We're just going to draw it together here. So we're going to make our relay, and we're going to install our 4 pins. So here we have 86, we have 85, we have 30, we have 87. Okay, so this relay is going to be a little different configuration. So we're going to take 87, and this is going to go to our fuel pump. Okay? We're going to take 85, and it's actually going to go to ground because we're using a Holley ECU. 86 is actually going to come out and it's going to go to the ECU trigger. Because Holley uses a positive trigger to take the relay. And then just as the other one, 30 is going to be power coming in. So we'll energize power to the relay. We'll energize it by sending power to 86. 85 will go to ground. 87 will power the fuel pump when the ECU demands it. So we're going to do another example here. We're going to actually work off of a 5-pin relay. I've had people ask me, what is 87A? And this will give you an overview of how 87A works. So we have 87, 30, 85, 30, 87. Okay, so on 30, that's going to be our power in, but this time, power in is going to come from the headlight switch. Okay, so when the headlight switch is turned on, it'll send power to 30. Now we're going to make a jumper that's going to power up 86 also at the same time. When this happens, there is going to be power in 87A. This is going to be low. Because when the relay is not activated, whatever C here will be C there. So now 85 is going to come out and go to the dimmer switch. When the dimmer switch is activated, it's going to actually send a ground back to 85, and it's going to energize the coil. When the coil energizes, 87A is going to be deactivated. Low beams are going to turn off, and the high beams will turn on. And when you toggle it again, it'll deactivate the coil and we'll go back to low beams. That's just a simple circuit showing how this 5-pin relay works. There's other applications for it, but nothing that we ever really use. So we are going to do a video on more information on relays, when we want to use them, how we use them, how to wire them. I'll actually build a couple of little relay panels. We'll do it step by step, and we'll put connectors on them, have them all ready to go in a future video, not